Hi, today we will be designing linked list. It's more object-oriented OOP task than so designing your implementation of a linked list. You can choose to use any string of double linked list. A node in a single linked list should have two attributes: value and next file. Is the value of if you want to use double linked list, you will need one more attribute prev to indicate the previous linked list, and assume all nodes in linked list as zero indexed, implement linked list class, initialize, get, index, add at head, add at tail, add at index. Okay, so add at index, add a node before the index node linked list. If index equal or the length of link, the node will be appended to the end of the link. If index is greater than length, the node will not be inserted. Okay. Now delete at index. Deleted index node linked list if the index is valid. Okay, so first we need class node. I don't know, should we implement like double linked list? Probably double linked list should be fine. Yeah, let's do class node, and class node will have constructor which will accept value. It could be 0. Then previous, right? Oh, so we are designing. Okay, next, and which could be no, none, right? None, and prev, which could be none too. And then we assign everything to self, meaning like here self val equal val, then self next equal next, self rel equals rev. So every time we create list, we have self head, right, equal nodes, then if we get, we have to go while so we assign some value, like running value we call self head, while r we and we have to do index, or we can remove index while r, or index more than 0. What we're gonna do, we're gonna do r equal r next, and at the end we just return r, and we decrease index equal -1, and we return r value, right? Then added the head, we create new node. Let's call it node with val. And then what we're gonna do, we're gonna assign r next equal self head, right? And we reassign our self head p equal r next. I'm not sure about, should we design like double linked list or single link? Yeah, let's do double link and see what happens. Okay. And then, so we assign here previous pointing on next, on R, and then we assign subhead equals R. At the tail, we have to do a kind of can keep tail, no? Okay. Or we can just navigate to the tail, to the last, while R, and then we go all the way down, then we assign R prev will be our, so R will be now, right? So let's introduce new last variable and we assign it to none. Then we assign last equals R equal next, and last next equal new node with value, right? Then last prev. We don't need last prev. We need only last next prev. We assign last, and that's it. We add it to the end. It's kind of I can do in one shot like this, right? Next and previous. No, last, next, prev. So of this, the next of this node will be now, but previous will be no. Yeah, that's fine. So adding insert and add the index, we navigate through index until we find our node. So if we index larger than length, it's not right, and then we can say if R, if R, only if we have node, we add it at this node. So it will be like page. Let's see. So this is our node R, and we have A and B. All right. Then what we're gonna do? We're gonna insert. We're gonna create new node. We call it. Wait. So we stopped at A. Okay, let's call it A. no, let's call it R, RB, R, and we add A. So A will be node with val. Next of this node will be B, meaning R next. Previous of this node will be R. So then we have to modify R next to I, and let's assign B as R next. So R next is I, and B is I. Yep. Okay, that's good. Deletion is the same. If we go through index, but slightly different. So we have this on first, we have A, we step on R, right? We step on R, and we have A and B. So what we're gonna do, we're gonna reassign A, B, which is R next, and A, which is R fifth. What we're gonna do, we're gonna assign B pref A and A next B. That's it. All right, seems good. So no value on indent. What? Okay. Yes. This node is not defined. Where is not defined? Okay. Bless you. So this is. Yeah, I'm trying to use the constructor as much as I can. Yeah, so add at the index. We have here and here. Okay, node type attribute to next return our val as of f. So if there is no get within, if index is invalid, return -1. Okay. So what I'm gonna do, I'm gonna say if not r, return -1. All right. So we're got 2 minus 1 and 3. So we add in as the head, next will be fabricating node with next. Then previous. Let's see. Yeah, I believe I had to. Add at the head, add at the tail. So we again at the head. So let's define printing function really quick. It should be n, obviously. This should be n. This should be n. And now so we add at the head. We can print here self. Yes, so we added at the head we add 1. Why we add a 1 at the head? Because we add in at head 1 and we have this one there. And then we add at the tail and it's nothing. Okay, so probably something at the tail. So we have last equal none. Okay, maybe R. R we kind of need this, but it's okay. So we move forward. Let's print it after this guy. Then we add the tail tree and repeat. Okay, so let's add here and then we address. And here we print result. We can do formatting. Right. Oops. Using parentheses and images. Okay, why we have 0 then? We add at the head 1. We add at the tail 3. Why we have the 0? Oh, we add at the head and we have a 0 because head is 0. So we have to keep like some kind of sentinel thingy. Yeah. So see, we have to keep sentinel. So let's say it's sentinel node. Or head will be sentinel. It's kind of confusing. So, let's name it to sentinel. And so we have to keep sentinel node all the time, but we are not printing it. Okay, let's review our code and when we get to do sentinel next. When we add at the head, So when we added the head, instead of we create new node and we have it like this. We have sentinel pointing to A. We add in node B. We add in node R. Now sentinel is pointing to R. We create new node R, which is now will be sentinel, whatever point on sentinel. Sentinel next. And previous will be sentinel. Then will be R. And we can say that I is whatever point in sentinel, whatever sentinel point in. Then our next node will be R, and then next will be which I is the same I, previous will be R. And that's it. And this is much better. I like it more. Non-type is attribute. Okay. I don't understand why it's not working. So we call an edit the head first, edit the tail next. The last. So we can say new node, right? And this node next will be null, none, and previous will be last. So we can say this will be new node. And this. Okay. But we will not identify why. Because A is. But what if A is not? It doesn't matter, we still create node R, and we attach it. We attach it to Sentinel, so we can say that Sentinel next is R. Okay, that works. Non-type was not really graph. Okay. We use this case. We didn't had one, and we did in the 0. Yep, should work. So we add 1. And we deleted the index 0. Deleted the index. So we see we got here, we are pointing to our first deleted the index 0, and we say non-type. Okay. So what if B is none, B3, B equal R next? So the instead R pointing to next, we assign to B. And we can say B I have a feeling this is not the last test case. Yeah, right. And so, okay. So we added the head 7, added the head 1, 2, right? 2. Added the head, added the head 1. Delete head index. What? Deleted index. Delete head index. use test keys. Num type is previous, same with B. Okay, that deletes 2. Yep. I need to see this beauty. Oh man. 40 minutes. 40 minutes. Okay. Add 3, add 0. Add 0, add 3. 0, 1, 2, 3. Perfect. Delete 2. 0, 1, 2. Perfect. Add 5, 0. So what is the problem? It returns 1, but it should return 4. Zero, 1, 2, 3. Yeah. Oh, it's index. It's correct. So get. Oh yeah, there it is. Yay! No, wrong answer. All right, -1. Supposed to be 20. Okay, so add is not working properly. Let's get. So what happens if I'm calling add edit index? And before the index node, if index equals a length, the node will be appended to the end. If index is greater, see we are in 0 to n. So and we have nothing. Okay, use this case. I can say if index equals 0, then we add a head. And we that's it. That's it. Oh, yeah, self. Amazing. The adding a tail one. So I can say if something is next. So we create new node with next and previous with Sentinel. A lot of special cases. Yep. Wow, 92. Nice. Okay, so obviously a lot of like spaces for optimization, especially this thing I added with add to the tail. If Sentinel is not if it's just Sentinel, maybe here too. But 92%. Yeah, I like it. Okay, this will be it for today. Thank you for watching.